Hi there, guys. I'm going to look at 8C and question 3, part C. There was no answer in the back in the digital copy of the book to this question. There was in the physical copy of the book, although I think there's a slight thing which is wrong with that as well. So I'm going to go through this one here. Okay, it says, of course, the transformation. Transformation that takes the graph of the curve y equals a sine bx minus c with these brackets plus d onto the cos graph with the same transformations is a horizontal translation of k times the period to the left. Take the value of k. Okay, well, I guess first thing to note is that A, B, C, and D are the same in both of the cases here. So they've both, the sine graph and the cos graph have undergone the same transformation. Second thing to note is that we do not need the A and the D. We don't need to consider those because those are only affecting the vertical direction. So it doesn't matter if you're scaling this whole thing up by a factor of 2 in the vertical direction, that will not affect the horizontal transformations. So we're only really interested in what's happening inside. If they'd have asked the same question, what takes you from this to this graph here, B, X, and C, it's the same answer. The A and the D aren't important here. Okay, well, let's have a little look at let's look at something basic. So from my point of view, I would build this thing up. So to start off with, let's begin with sine x and cos x. Let's see what happens there. Let's see what we need to translate by. So you can see from sine x to take you to cosine x, well, here's the top point of sine x at pi over 2, or 90 degrees. And to take you to cosine of x, you're going to need to go backwards by 90 degrees, or pi over 2. Or you could consider it as well as going forwards by 3 over 2 pi, or 270 degrees. But I'm going to use the smaller distance here. I'm going to take it backwards by pi over 2. So the translation that's required here is, well, if I did, let's actually write it down. So let's do y equals sine of x minus pi over 2. Hang on, sorry, I wanted to go backwards. Plus pi divided by 2. Okay, I want to go backwards, so I put a plus in here. Okay, it's always the opposite to what we expect. And so that's taken us to the same graph. That's the same as the cos graph. Now the actual transformation, though, in that case, let's go back to here. Let's just get rid of everything for a moment. Okay, so if we were going to go from sine of x to cos of x, well, it's true to say that cos of x is equal to sine of x plus pi over 2, but the translation that's needed is minus pi over 2 because we're going backwards by that, and a 0 upwards or downwards. So that's the transformation which is required. Okay, well, I'm going to build this up a little bit again because obviously that's just sine of x, and I can see there's a b in front. So I'm going to use the b now instead. So again, I want to take this slowly, so I'm just going to see what's happening. I'm going to put 2x there, and I'm going to put 2x there. Now you can see my green graph does not match to what I need, so let's take that one away. So here we can see we've got the sine of 2x, which is stretched by a factor of 0.5 from the original sine graph, and the same with the cos graph. So now, instead of having the top point at pi over 2 for the sine graph, we now have it at pi over 4. Okay, half of that distance there, or 45 degrees if you want to do it in degrees. Okay, so to take us back to this point, we now have to go back by pi over 4. So when there wasn't a 2 there, we went backwards by pi over 2. Now there's a 2 there, we go backwards by pi over 4. Okay, let's crop this thing here. Okay, and just go through that. So we're going backwards here backwards by pi over 4. to take it to the same thing. So the transformation you're going to need to take you from here to here is now going to be inside these brackets, we've got minus pi over 4 and 0. Okay, well, remember with sine of x to cosine of x, that was transformation that was required was minus pi over 2 and 0. So by adding in this 2, we've now had to divide this thing by 2. Divide the k, if you like, by 2. So you can imagine what happens if we go to sine of b of x and then to cos of b of x, what takes you from this graph to this graph? Well, we're going to now need to divide the original thing, this thing here, not by 2, but by b. So we've got pi minus pi over 2. We'll put that b on the bottom there as well. So that's going to be our transformation that's required. Okay, so let's have a little look at that one. Let's build it up again. So let's put in here let's put b of x. It's going to ask us to add the slider. And let's put b of x in there as well. And we've got 1 in that case. But let's take that original graph and let's actually call this f of x at the start. Then we can do a nice easy transformation of f of x. And let's now do f of, and let's push it backwards by, what did we say? We said pi over 2b. So let's push it backwards by that. So let's put inside these brackets x plus pi over 2b. Okay, and let's close that one off. And we can see it's taking us backwards to the black graph here. So it's taking us, the original sine graph is now on top of the cosine graph, which is the blue graph. And you can see that we took this out to 2. Okay, that would be what we did before. So now that's taking us in by pi over 4, which is going to be pi over 4 when I have b is equal to 2, and so on. So this is always taking us that point, whether we push it outwards or pull it inwards there. Okay, so final little bit then is to decide what difference the x minus c has inside the brackets as well. So let's put on some brackets and some brackets here, and let's put some more brackets on the inside, and let's put a little minus c here, and this bracket on the end there. So there's the original, and we need a slider for c, of course. It's just coming up as 1, and let's do the same thing on this one here. Let's put in the x minus c here. Just fill this one out. Oh, sorry. Okay, and you can see that in fact the minus c is pushing this graph forwards or backwards, but the distance, the stretch is still the same. So the transformation between the two is still going to be the same, which is why my f of x, my transformed f graph is still the same as, hang on a second, I've lost it now. Let's put in y equals cos of b, and then let's do x minus c, brackets, and you can see that the black graph is the same as the blue graph here. In other words, it doesn't make any difference having that minus c inside, because that's just pushing it backwards and forwards, but there's the same distance between them. The distance between them is defined by the stretch, not by the transformation. Sorry, translation. Okay, so those two you can see are going in the same direction. So, in other words, the transformation that's required is this between sine of bx plus c and cos of bx plus c in those brackets is minus pi over 2b. Now, if I start adding, let's put an a here and let's put a plus b on the end, plus b on the end. Okay, let's add sliders for all of those, and let's put the same on this cos graph. You'll see I'm going to put an a, and I'm going to put a b on the end there, plus d. And so I'm going to put that on here as well. So we do a, lots of f of x, and plus d there. Hang on, what's happened there? Let's just pull it out. It should be the same. Hang on. Right, let's just get rid of some of this stuff here. Right, okay, let's get rid of that. So yeah, so to take you from this one to this one here, it's still going to be that same shift. So if I now do f of, what do we need? We needed that shift of plus pi over 2b. Yeah, it takes you to the same thing. I was a bit concerned there for a moment. It takes you to the same thing. It's still the same shift. The a and the d, it doesn't matter what you do with those. That's not affecting the translation that's required. Likewise with the A, that's stretching it out, but it is not affecting the translation which is required. The only thing which affects it is the B. Okay, that's the only thing which affects that translation. Okay, right then. Sorry, this is going on a bit, but to go through the final part of this question in the book, it tells you to answer this question. It says that K is equal to pi over 2b. And look, we've got here minus pi over 2b. Well, I think the book is wrong there. We know that we actually need to go backwards by this. So this is the vector translation which is required. So this is good. There's a missing minus there. Now, actually, the book, I think, is wrong in another sense. And I will go into why. If you want to just skip out now, you can, because it's getting a bit technical. Because I think the question is wrong. So I think that that's what they were trying to ask, but in fact, they ask something different. So they say the translation is this. The thing that takes it is a horizontal translation of k times by the period to the left, times by the period. Okay, basically. So k times the period. Well, we'd have the period of these graphs is k is equal to so the period is 2 pi over b. Now, k times the period is this. If that's the translation, well, we know the actual translation minus pi over 2b. And this is state the value of k. Well, that's the thing I've just worked out previously. This is setting up the question, because they've said the horizontal translation k times the period to the left. So k times the period is this. And therefore, you'd need to solve that. Actually, I'm now thinking the book is right, because there's a translation to the left, doesn't it? So, sorry, pi over 2b, pi over 2b 0 is the translation, but it's true to say that if they're saying it's to the left already, then you don't need to put in that minus. The book is right in the back, so that's good. Okay. Anyway, I think that if we still put in the plus here, change that to a plus, just change my mind on that one. If we set up what the question is asking here, then we'd need to solve this to get that answer for k. And I don't think that's what they mean. Okay, they should get rid of this thing here in terms of the question in order to answer it right. Okay, guys, sorry for my little mistake there with the minus. It was kind of, I was answering just a slightly different question myself. Okay, hope that helps. Sorry that goes on a bit. Ask me any questions if need be.